Take a look at question number 20. So here it says a cube has 6 faces. Each face has some dots on it. The numbers of dots on the 6 faces are 2, 3, 4, 5, 6, and 7. Okay, so it's kind of like a die, right? It's kind of like a die, but instead of the usual 1 to 6, it goes up from 2 to 7. And then Harry removes one of the dots at random, with each dot equally likely to be removed. Okay, so when the cube is rolled, each face is equally likely to be the top face. Yep. What's the probability that the top face has an odd number of dots on it? Okay, so normally, if it's not removed, if one of the dots is not removed, what would be the probability that the top face has an odd number of dots on it? Like if it's just a regular, if it's just the initial case, then 3, 5, and 7 are the odd ones out of 6. So you for before removal, it would be 3 out of, so the probability of odd would be 3 out of 6, or 1/2. So now when we removed one of the dots at random, it changes things. So after removal, let's say if we removed, I'm going to use a different color. So after removal, if we remove the 2, then the 2 becomes odd, right? The 2 becomes a 1, which is odd. So the 2, the 4, and the 6, they have the possibility of becoming, so they can become odd. Whereas the 3, 5, and 7, if you removed a dot, it wouldn't become odd. So, and in fact, it would increase the probability that you would roll an even. So I would say, since the probability of removing these at random, it doesn't change the probability, because you're equally likely to make something, you're equally likely to increase the probability of creating more odd numbers. So in 1/2, so removing half of the time you create increase, so p odd increases. The other half of the time p odd goes down, right? So let's say you removed one of the, either 2, 4, or 6, remove the dot from 2, 4, or 6, the probability of the odd increases to 4 out of 6. But if you were to, the other half of the time, you're removing from 3, 5, or 7, and you just created more even numbers. So the probability of the odd numbers decreases to 2 out of 6. So I think, okay, so what's the probability that the top face has an odd number of dots on it after removing? On the surface, it seems like it shouldn't change the probability, right? Because 1/2 of the time, you're going to end up with 4 out of 6. And the other half of the time, you're ending up with a probability of 2 out of 6. So what's the total probability? P odd so that is equal to 1/2 times 4 over 6 is just 2 over 6 plus 1/2 times 2 over 6 is just 1 over 6, which is equal to 3 over 6, which is exactly as we expected. It's exactly the same. It's still 1/2. So B should be the answer. Look at the answer key, and it turns out my solution is totally wrong. So what I had, where I had messed up is I thought that Harry removes one of the dots from a random face, but in fact, the question says Harry removes one of the dots at random. So that's a totally different interpretation. What this means is that there are 27 dots, so 2 plus 3 plus 4 plus 5 plus 6 plus 7 is 27 dots. And he removes one of the dots at random, instead of picking a random face and removing a dot. So what this means is that this changes our probability here and here. So essentially, if he picks, let's say he picks one of these ones. So if he picks one of, we can calculate what the probability is that he picks from one of these ones versus one of the like 3, 5, or 7. And if he picks from the green circle, the ones that I circled in green, then we're gonna increase the probability of the odd numbers to a 4 over 6. But if he picks the blue underlying ones, then we're gonna decrease the probability to a 2 over 6, probability of getting an odd number to 2 over 6. And it turns out that it is less likely to pick, if we're just picking a random dot, then there are more dots in the 3, 5, and 7 compared to number of dots in the 2, 4, and 6. Because 2 plus 4 plus 6, 2 plus 4 plus 6 is, so let's do the calculation here. 2 plus 4 plus 6 is 12, right? So 12, and 3 plus 5 plus 7 is 15, right? So it's 12 out of 27 total dots, and this is 15 out of, so he can either remove this one or remove this one. And these are the probability, this is the probability breakdown. And if he goes with this probability, he goes with this scenario, then we have a 4 out of 6 chance for getting an odd number. If he gets the 3, 5, or 7, the 3, 5, or 7 faces, then we have a 2 out of 6 probability. And these are mutually exclusive, so we can write the final thing kind of in a similar way for the final probability, where there's a 12 out of 27 chance for choosing 2, 4, or 6, and in that case the probability of odd increases to 4 over 6. And then there is a 15 out of 27 chance that he picks one of the other faces, 3, 5, or 7, in which case the probability of tossing an odd decreases to 2 over 6. And if you add up that probability, then you get then you're going to get, so this will be, let's just cross that out. So 12 out of 27 times 4 over 6. So we can do 12 divided by 6 first. 12 divided by 6 is 2. 2 times 4 is 8. So that will be 8 over 27. And then we can do this one next. 2 over 6, we can simplify this as 1 over 3. And 15 divided by 3 is 5. So this will simplify into 5 over 27. And then if we were to add these fractions up, we'll get 13 over 27. So that's the final answer. And I know it's right this time because I checked the answer. And that is indeed the answer, which is C, not B. So this is just a really good lesson for me to always read the question carefully. Don't just assume what the question is asking. All right, thank you.